Hello, and welcome to our presentation on the Guardian Angel Carsafe project. Today, we'll explore how this innovative device aims to enhance child safety in vehicles. Let's begin. Did you know that every year, countless parents accidentally leave their children in cars? This oversight can have tragic consequences. Our project addresses this critical issue by developing a device that alerts caregivers if a child is left unattended in a vehicle. Many busy parents often forget important things, like their children, due to work-related stress. This can lead to dangerous situations, such as leaving kids unattended in cars, which poses serious risks like lack of oxygen and high temperatures. To prevent such incidents, it is essential to implement safety measures, such as using an alarm system in vehicles. In Malaysia, the government is taking steps to address this issue by recommending practical solutions. These include placing the baby seat behind the front passenger seat to avoid blind spots, keeping valuable items in the back seat as reminders, using tags on the gear stick, and informing partners or caregivers if a child is not where they should be. People often forget things, especially when they are in a hurry. This forgetfulness can lead to serious consequences, such as parents accidentally leaving their children in cars after returning home late from work. Tragically, there have been numerous cases where babies and toddlers have died due to being left unattended in vehicles for extended periods. This highlights the imminent danger faced by children in these situations. The primary concern is the safety of the child left inside the car, as they are at risk of extreme temperatures and lack of ventilation, which can significantly impact their health and well-being. Our project has three main goals to improve child safety in cars. First, we want to design a device with an alarm system that alerts parents if a child is left alone in the car. Second, we're developing a notification system that helps prevent dangers for children left in vehicles. Finally, we'll test the alarm system to ensure it works effectively. By reaching these goals, we aim to make a real difference in keeping children safe. Our project aims to create a car alarm system that alerts parents if a child is left in a vehicle. It's designed for busy parents with young kids in cities in Malaysia. The device uses a rechargeable 2000 mAh battery that needs weekly charging and is small, measuring 10 cm by 6 cm by 4 cm for easy installation. It has motion sensors to detect movement and temperature sensors to monitor heat, all controlled by an Arduino. The system includes a GSM module that sends alert messages using a SIM card, which may have costs. The buzzer is loud, at 85 decibels, to catch parents' attention. The device works in different weather conditions, handling temperatures from -10 degrees Celsius to 60 degrees Celsius and humidity up to 90%. It requires regular battery charging and may incur telecom costs. Overall, our goal is to provide alerts to help prevent children from being accidentally left in cars, greatly improving child safety.
Our methodology involves several key steps to create our car alarm system. First, we gather all the necessary components required for the project. Once we have everything, we connect and initialize the system to ensure it functions properly. Next, we set the parameters for the sensors according to our specifications. After that, we activate the sensors to begin monitoring. The system will continuously check for specific conditions. If it detects motion, pressure, or if the temperature reaches a certain threshold, it will trigger an alert. This process ensures that our device can effectively notify parents if a child is left unattended in the car, enhancing their safety. Our project is about creating an alarm system to keep children safe in cars, especially to stop them from being left alone. The system uses motion sensors and force-sensitive resistors, FSR, to check if a child is in the vehicle. It works with a GSM module and an Arduino microcontroller to send alerts to parents or caregivers in real time when a child is detected. This way, they can act quickly to keep the child safe. The system runs on a rechargeable battery, so it works even when the car is turned off. This project is very important for protecting children and giving peace of mind to caregivers. We also plan to make improvements in the future and explore working with car manufacturers for better solutions. In this section, We'll look at how the components are connected in our system. First, we have the Arduino, which is the main part of our system. It connects to the IR sensor that detects movement inside the car. When the sensor sees movement, it sends a signal to the Arduino to check if a child is present. Next, we have 3 force-sensitive resistors, or FSRs. These sensors detect pressure and are also connected to the Arduino. Each FSR is placed in specific spots to see if a child is sitting in the car. If any FSR detects pressure, it tells the Arduino that a child is in the seat. Now, let's talk about the GSM module. This module is connected to the Arduino as well. When the Arduino gets signals from the IR sensor or the FSRs, it uses the GSM module to make a missed call to parents or caregivers. This way, they can be notified right away if a child is left alone in the car. Together, these parts work to keep children safe in vehicles.
Okay, so sini boleh lihat dua parent sistem dah on, lepas tu ada dua parent dengan baby occupied. Lepas tu bila macam contohnya kalau baby tu keluar, parent keluar, baby ada kat dalam atau budak, nanti dia akan bagi tahu child is inside the car, lepas tu nanti dia akan bagi miss call. Miss call dalam 2 minit dia akan call lagi sekali, tapi tak miss call lah. Okey, itu saja. Okay, so
This demonstration focuses on the force-sensitive resistor, or FSR, and how it triggers a missed call. First, let's look at the FSR. This sensor can tell when someone is sitting in the car by detecting pressure. Now, we'll show how it works. I'll place some weight on the FSR, simulating a child sitting in the seat. Watch closely as the Arduino detects the pressure from the FSR. Once the sensor confirms that a child is present, everything is working as it should. Next, let's see what happens if the child is left alone. If the FSR does not sense any movement or pressure for a set time, the Arduino will activate the GSM module. As you can see, it's making a missed call to the parent's phone. This call alerts them that a child might be left in the car. This feature is designed to help keep children safe by ensuring parents are notified right away if a child is left unattended. This project addresses 3 important sustainable development goals. First, under SDG 3, Good Health and Well-being, it aims to prevent road injuries and deaths by ensuring children and other occupants are not left in cars, avoiding serious health risks like overheating and dehydration. Next, it supports SDG 9, Industry, Innovation, and Infrastructure by encouraging new ideas in car safety technology and improving vehicle safety. Finally, it contributes to SDG 11, Sustainable Cities and Communities by creating safer car environments, especially for vulnerable occupants like children, thereby enhancing the overall safety of transport systems for everyone. For future recommendations, a key enhancement for this project is integrating GPS tracking. This addition would allow the system to send real-time location data along with emergency alerts, enabling caregivers or responders to quickly locate a vehicle if a child is accidentally left inside. When conditions like excessive temperature or sensor pressure are detected, the system would instantly send alerts with the car's location. This improvement would significantly increase the system's effectiveness, making it a crucial tool for saving lives by guiding emergency services to the vehicle. In conclusion, this Arduino-based safety project provides a practical solution to keep occupants safe in vehicles. By using FSR sensors, a GSM module, an infrared sensor, and a DHT11 temperature sensor, the system can detect when children or vulnerable individuals are left alone in a car and alert caregivers with phone calls. The temperature monitoring feature helps protect against dangerous heat. This project tackles important safety issues and supports innovation, leading to safer transportation and showing how accessible technology can enhance everyday health and security. Thank you.